All right, so the next question involves calculating the ideal effort force needed to overcome a resistance of 1,200 pounds. So this is, I left this up from the previous calculations of calculating ideal mechanical advantage. So we have that number sitting right here, 11,760. The formula I want to use is, well, if you remember AMA, the AMA formula, if you remember, was force resistance over force effort. So I'm able to look at the two forces to get actual mechanical advantage. So they want me to calculate an effort force. They want to give me the resistance force. So those are two knowns. And I have an ideal. So I can use this formula if I rewrite it a little bit and say IMA is equal to the resistance force over the force of ideal effort. So the only difference that I'm going to get, because you're using the same concepts in the same places, the only difference is this is in an ideal world. Again, it's saying calculate the ideal effort force. So we're not taking into account an actual measured amount of effort force put in. They're giving it to us. So that's where this comes from. We're just taking the force and the resistance and dividing it by the force of the effort. And that's why I'm going to put this in down here. Divided by force. And I'm going to put the I in there, just, it's not the word phi. It's force of ideal effort. It's kind of blurry probably for you, but maybe it's just my eyes. So that gives me the substitution of 11,760 equals the force of resistance. They're telling us that here. We've got to overcome 1,200 pounds, so I put that up on top. And we want to solve for the force of ideal effort. So there you go. Algebra, 1,200 divided by 11,760. So I pop that into my handy dandy calculator and I get 0.1, I'll just round that to 2 decimals, 0.10 pounds. That's pretty amazing, actually, if you really think about it. I can produce 1,200 pounds with a tenth of a pound of force. Okay, very, very impressive. Now, I will tell you from experience that there's a tremendous amount of friction involved with fasteners. So you would not see a very high efficiency in fasteners. Generally, they're down to about 30–40% efficient, if not even lower than that, just because of all the surfaces that are touching and making contact as a fastener moves its way through the cavity or the void, if you will, of the hole. So, but even so, you're still able to accomplish a lot of a mechanical advantage with threaded fasteners. That's it.